Hey everybody, I'm Johnny. I am a DevOps engineer, cloud engineer, system software engineer. I've done a lot of things over my career. I've been doing infrastructure for a while, and that's what I'm talking about today. I'll talk about design patterns in infrastructure code. So just very casually, half people's jobs is dealing with Terraform or CloudFormation or just cloud, whatever, building resources, or it used to be. Okay, so hopefully this will be nice for everybody, but that's a lot of my job. So I've been doing infrastructure as code since CloudFormation first came out. I've been doing it for a while. I've been very impressed with what we've done so far. We've done a lot of very good things with infrastructure code over the time we've been had time to do it. Getting into source control was huge. I remember having these 200-page Word docs of how to set up a server. The fact we don't have those anymore is great. And it allows for reproducibility. So now I can create the same environment 2, 3, 10 times, which we definitely couldn't do before, even though we live until we could. And reusability so that you can say, hey, I built this thing to make an EKS cluster or whatever. Now you on my team can also do it, you across the company can do it, you in the broader community can do it. That's awesome. And more recently, tools like Gloomy and CDK have made it so that you can actually use real actual coding constructs more than just fancy YAML. So we've made a lot of progress in infrastructure code in the past 10 years. We've missed a couple key lessons, we've forgotten a couple things, where we've been pulling stuff over from, hey, how applicants do it, let's see infrastructure code. One thing we missed is automated testing. That is a really big thing for developing app code. Not such a big thing for infrastructure code. Another thing we'll talk about tonight is design patterns. They're a very big thing in app code that we don't really have in infrastructure code. I'm not going to talk about automated testing tonight. You look like CPU.
Yeah.
But I'm going to talk about automated testing tonight because I do not have a good story for it. But then we're talking about design patterns. If you're not familiar with what a design pattern is, I jacked the definition from Wikipedia. But it's just it's very similar to a pattern in garment making. It's not an actual garment, it's just something you can use to make one. So design pattern in code is not actual code, it's just a way you can write your code to achieve what you want to get. More maintainable, make it easier to change, make it performance. But the idea is just a named pattern that you can then talk about rather than having to describe it over and over again. So why did we do this for infrastructure as code? What I found is a lot of this best practices we say we use infrastructure as code, we kind of just take it from best practices in app code and said, okay, we're going to do this here. And we never really thought about if that makes sense. And what we run into is some things that make a lot of sense for app code break down hardly for infrastructure code. And because we don't have any good design patterns for what good infrastructure code looks like, we're kind of lost. So it took me a while to figure out why this was the case. I didn't get it at first. So we're very quickly think I think this is a very crude example that I tried to do a whiteboard example on the slide, so I apologize for that. So software looks like this. So you have a code, it has inputs of some sort, a parameter, database lookup, a file, whatever. It has outputs, which can be return value, a database write, file write. This is very simple, but I think it's accurate for how software works. We've been thinking about infrastructure as code like this. Oh, it just fills the same niche. Takes inputs, because a lot of our tools actually have a inputs and parameters section, and then has an output section that creates cloud resources. So this seems like it's right, but my thesis is this is wrong. We shouldn't think about infrastructure code like this. We should actually move infrastructure code as an input to actual code, your Terraform, your CloudFormation service. Infrastructure code serves as an input to something else that then produces things you want. which is I think a key distinction. But there's two other things that I think we miss when we think about it like this. There's two other inputs. One is the actual existing infrastructure, which is super important, and we just don't kind of consider it. And the other is the state file, which we all just kind of pretend doesn't exist because it scares us. And those all feed into the Terraform binary, the cloud formation service, to produce our outputs. And when you think about like stuff like this, it changes how you do stuff. Because it's different. It's similar, but it's different and you treat it differently. So what does that look like? How do we treat this differently? So we've been thinking about taking these processes from application code. A lot of like the best practices on app code are designed to make application code easier to change. I'm like, oh, well, making infrastructure code easier to change seems like a good thing too. But it bites us because it's very easy to change infrastructure code. It's very hard to change actual infrastructure. I liken it to a blueprint in the house. Back to Total Talk. It's very easy to change a blueprint. I've never actually done a blueprint, but I assume it's a lot easier than changing your actual house and moving your bathroom from the first floor to the third floor. I know that's hard. I've never done that either, but I've seen people do it, and it's very difficult. A blueprint can be done 2 hours, I don't know, less time it takes to move a bathroom. So I've thought about ways that we can do our infrastructure code to make it easy to change infrastructure. And that's these I kind of try to talk about. The downside is sometimes those changes, those design patterns, actually make the code itself harder to change. And I'm offering, I think that's a worthwhile exchange. Taking some upfront pain to have harder infrastructure code that makes infrastructure easier to change later is a good deal. So let's just talk about. I broke it up into 3 sections: architectural patterns, code patterns, and techniques. Architectural patterns are how to architect your infrastructure. It's not stuff you can go and do tomorrow, but it is stuff you want to think about when you're starting your project, or if you're taking over a major re-architecture of your app. So you're going to do it. Code patterns are stuff you can start doing tomorrow. If you're refactoring your infrastructure code, there are things to think about. Techniques aren't really design patterns. But there are a lot of things I think are important that I kind of throw at the end. I'm just going to rapid fire go through and fill some marks in the way. So let's get into it. Architectural patterns. So the first one I'll talk about is the first thing I actually learned about infrastructure code. You want to group your resources by their life cycle. And that's just a way of saying, like, if it's created, updated, and deleted, it should live in the same project. If these 2 resources have different creation, update, delete schedules, they should live in separate projects. And that's easy, and people are nodding, saying, oh, that sounds reasonable. But what does that actually look like in reality? Oh, sorry. These are the benefits of that. It limits blast radius. So if your database and your compute are never updated at the same time, but are never changed at the same time, but updated in the same template or same project, you could make a change to your compute and like accidentally blow over your database. Blast radius. It'll run faster. If anyone has ever had a giant Terraform project with hundreds of resources, and it took 10 minutes for it to like scan everything and figure out what's going on, that sucked. If you have a smaller projects, they're going to do that scan faster. And it limits cognitive load. And cognitive load is a term I'm going to throw out a bunch today. This is a very fancy way of like keeping what's in your head, what you have to keep in your head. So for a large project, you have to think about all the resources going into it. For a smaller project, you have to keep a smaller number of resources in your head. Cognitive load. Limiting cognitive load is advantageous when you're working on stuff because you don't think about everything at once. Think about as many things. Anyway, it's easy to say you should do these things. It's hard to see how you actually should do it. So I'm going to walk through an example of like a simple 3-tier web app, network compute persistence. And I'm going to go through like maturity model that I've observed, having dealt with this a bunch of times. So the first way people tend to group projects is by environment. So, and that makes sense that people do it that way, because you're going to create an environment largely at the same time. If you decide to get rid of the environment, you're going to delete at the same time. Updating it's kind of iffy, but another big reason people fall into this is because this is how every example introduction to any infrastructure code tool comes. It's like, okay, set up an environment, and here's everything you need, just get started. And it works until you get a second environment. And then things start to, you get some friction. So if you're deploying new versions of your app by updating your compute, you're doing that every day, every week, every month. But you want to say, hey, I'm going to try a new version of our database. You want to run that in dev for a couple weeks. Now you're stuck because your dev environment, you change the template for your dev environment, but you don't want to deploy that change to production, but you still want to deploy changes to production with your compute. So things get messy pretty quickly with this. So what people tend to go for after this starts to break down is grouping by resource type. And this has advantages. It does kind of lower cognitive load in that if you're like, I need to change the database, I will go to the persistence project and do that. And it does limit blast radius a little bit, because like if you're making a change to the network, you're definitely not going to mess with the database. But you could be messing with the database for non-prod, edit the wrong file, and you can, oh, now I just turned off the production data. Didn't mean to do that. So this breaks down eventually too. And then people kind of react very, very aggressively and say, screw it, I'm just putting everything in its own project. Which I don't think is entirely wrong, but I think there is some nuance here. There's lots of types.
Can I ask a question real quick? When you're talking about this, and you kind of alluded to it, like the blast area, but it's almost like a subject area. You might call it a project, but it's who is the custodian of what is the project as to what is its dimension on whatever cloud you're talking about. So you have to account for the VPC. You have to know what is contained in your VPC, and therefore that is what is going to be your infrastructure as code as well. Things outside of the VPC also have to be accounted for. Let's say you're using Lambda, or you're using an S3 bucket for some reason, because your infrastructure of code has risks with it as well, because you might have to inject passwords into it. You might have to have a password for the database. You might have to have some type of encryption that has to be updated so that you can run these things. These are the things that weigh on me when people go outside and want to take a swath of, I want to be the databases, I want to be the CPUs, I want to be the front end.
What's the question?
Is that what you're talking about? In sort of.
So not so much the custodianship, but more like how you break out the operation template or the Terraform project, so that they will be here. So you could have a ton of projects all owned by one team or by multiple teams. So I do think there is a very good conversation to be had about who owns that stuff and who's responsible for taking care of it. I think that's a bit deeper than I'm going to make.
Sorry.
No, it's fine. No, it's a good question. Anyway, so you get to the point where you're like, okay, I have been burned every which way. I'm just going to put everything in its own project. And then you have a ton of little tiny projects everywhere, and that makes you angry too. I think this is not a terrible approach. I think this is a nuance. I think instead of saying every resource gets its own project, I've been referring to it as every primary resource gets its own project. So I'm going to focus on compute, but say you have an EC2 instance. It's a primary resource, but there's a lot of supporting resources. So we'll have what we attach an auto server. Has something there. It will, it'll have a security group. It will have an cloud module run. It will have an iron role. It will have the volume attachment, and it might even have a code deploy config attached to it. And And all those things make sense to live with that EC2 instance in that project. And what you find is that all these primary resources will have these type of things. And this is what I found is like the best way to kind of group your resources. Find out what your primary resources are, and they won't always be the same resource. So like an IAM role is probably a supporting resource for all of these, but an IAM role can also be a primary resource by itself for a certain application. And I think a lot of things kind of work that way. So you gotta think about, there's definitely like room to play with it, but grouping by primary resources and supporting resources is how I kind of found is the best way to kind of work with these things. And we talked about, I mentioned there were horror stories. A time this went wrong, I was working at a place, and I was asked to scale down the Redis cluster in our demo environment. We were running multi-AZ for some reason in the demo. It was used twice a week, it didn't need multi-AZ. I go in, I do it, easy peasy, delete the secondary node. Weeks go by, and then I'm asked to update our CloudWatch alarms. In fact, I'm telling the story right after these two events right after each other. Makes it very obvious it's going to happen. But at the time, I was very confused when I ran the Terraform for the CloudWatch. It's like, here's the change you wanted to make, but also I'm going to leave these alarms over here. I'm like, why do those alarms want to go away? So after talking to my team, digging through the code, I realized that the CloudWatch alarms were grouped by resource. All the CloudWatch alarms for our entire project lived in the CloudWatch alarm project. So it detected, hey, there's a missing Redis cluster, I'm going to leave the CloudWatch alarms for that, which should have been done, correct, but it took me several hours to figure out that I actually did want to do that as a leak. Whenever a Terraform says it wants to leak something, and you're like, I don't know what that is, you kind of freak out. So it was not like my favorite day. So it wasn't a huge deal, but it did waste time, stressed me out, and I eventually moved on CloudWatch alarms so that was the thing they were alarming on. It's also probably kind of worrisome that like the Redis instance was missing for 2 weeks. Alarm was there for it, but didn't go off. Anyway, group yourself by life cycle. Primary resources with supporting resources. It's a nice way to do it. Next thing I want to talk about is immutable infrastructure. Immutable infrastructure is this idea that you never update a resource. You only ever create a new resource next to the other one, cut over traffic, whatever it means for that resource, cut over traffic, and then you delete the old one. This was something that was a big deal in like the mid-2010s. It has fallen out of popular consciousness for reasons, I think I suspect why. But if you've heard of blue-green deployments, that term originated with immutable infrastructure, although now we use it for a lot of other different types of deployments. But up until like 2 or 3 versions ago, Kubernetes would manage pods in a immutable way. You couldn't change a pod. If you'd like a force update, behind the scenes, you just delete the old one. Well, create a new one that delete the old one. Then you screw that up and make it go away. Actually, update from that. I love immutable infrastructure. I've done entire talks on immutable infrastructure. I think it solves so many problems. It makes testing super easy because you set up your new updated resource, you can just like play with it, and no traffic's going to it, no one's gonna be mad if you screw anything up. You can test to make sure it's working. Once you're confident it's working, you just cut over, and it turns out, oh wait, things aren't working. Rollbacks are super easy. You just like, okay, send traffic back to the old resource and figure it out. And it's really easy to do a change because you're not changing anything. When you run your Terraform apply, you just get a bunch of green, add. You don't have to go through and be like, okay, is this little thing I'm gonna change? Okay, cool. Is this thing gonna change? Cool. Is this thing gonna change? Maybe, I don't know. Let me go talk to another engineer on my team and make sure that's right. So when you're doing setting up your stuff, it's so much easier. And the reason I like this for as an infrastructure as code pattern is because we all lie to ourselves about being able to test our infrastructure code. There's no way to test your changes to your production environment because of the saw that earlier. Your existing info in your shapefile are inputs to the change you're making, and you can't test those in non-prod. You can like pretend like, hey, well, it's the same environment, it's all scaled down. Scale makes a difference. But even if you could run the giant, huge database you have in production in non-prod too, the load wouldn't be there. And making a change to a database running with 5% load versus 95% load has different effects. It just takes longer to make the change. So with immutable infrastructure, you don't have existing infrastructure, you don't have a state file. The thing you're doing is creating, and you can test that pretty reliably in a non-production environment.
So they're not looking for a pre-prod environment to test this out on because of size, the cost.
Yeah.
Okay.
So I'm making this sound really easy, but there are some downsides. For at least some portion of the time, you're managing two sets of infrastructure. And depending on how long you have to keep these two instances running at the same time, these resources running at the same time, that can be a while. It can be very slow. Security group change versus a security group update, security group creation versus security group update is about the same amount of time, 2 seconds. An EKS cluster creation versus an update can be minutes, hours. So it can be very slow and it can be very expensive. If you're running 2 giant EKS clusters at once, that can be expensive. And really, those are just stale resources causing problems. So stable resources cause lots of problems with immutable infrastructure. Stateless resources are great. So definitely use it for that. But I really recommend everyone use immutable infrastructure everywhere you can. But if you can't, there's a pattern. I've been calling east-west deployments. There's something I made up, so you're not going to find it on the internet anywhere. But what we will find on the internet is something called hot or active deployments. They are more known for when you're doing like business continuity disaster recovery architecture. But they're less, but they don't really tell you how to like deploy to those. Or sometimes they do, but not often. When I talk about east-west deployments, I'm specifically talking about infrastructure deployment. But the idea is the same. Instead of having 1 EKS cluster, you have 2. And they look exactly the same. You split traffic between them. You put all the same stuff on them. And when you do a resource, or you do an infrastructure update, you do it to 1 resource at a time. And this is good when resources take a long time to create, like an EKS cluster. Or have a lot of state on them, like an EKS cluster. Or both, like an EKS cluster.
So do they do that with a large database as well?
Okay.
Okay.
I get that, but I get that really excited. But the idea is you make a change to each resource. If it goes well, you just go to the west resource. If it goes badly, you fail over all traffic to the west resource. Just mute it. You don't even try to fix it. It could be like a 2-minute fix, it could be a 2-hour fix. You don't know. Just fail over traffic, and that way you can deal with it in a non-stressed out, oh god, I took down the prod type way. When you start your ship deploy, you probably want to scale up your west resource just in case. So for EKS, you probably want to double the size. For the database, you want to horizontally scale it. This does require you to have an ability to fail over quickly, and that's not always easy. It requires some automation. You have to think about it. Compared to immutable infrastructure, you do lose some ability to test. You do increase cognitive load a bit because now you have to like keep 2 resources in your head and treat them differently. You still can roll back quickly, which is nice. It can be very important. How you work with them can be tricky. If you're doing this with Kubernetes, how do you make sure you have all the same Kubernetes resources deployed to both clusters? This is a solved problem. It's not an easy problem, but there are solutions. For databases, how do you make sure they're in sync? Again, there are solutions to that problem. They're not easy, and generally they're not cheap, but there are things you can do. So if you do want to roll out that change to the database and like, okay, well, in this case, do you have root replicas or imports one to a right? Do we have we have like a leader node and supporting nodes, so you can then like elect a new leader. Solve problems. Not easy problems, but solve problems. When does that problem? I saw a dev environment completely burned because we did this incorrectly. I was actually working somewhere where we had EKS, or actually it's Azure, AKS clusters, and we were doing east-west deployments for prod and demo, but not for dev, because it is more expensive, especially if, like, with prod, you're like, okay, I'm gonna half load on each of these. For dev, there's no load at all, so it's like, we'll just run one cluster, and it's down for an hour, no one cares. Until we tried to upgrade Kubernetes, realized the upgrade failed, and there's no way to roll back. For as far as I know, no managed Kubernetes service lets you roll back your Kubernetes. The only thing you can do is create a new one. So we tried to upgrade dev, it failed. Half the team then spent the rest of the day trying to figure out how to set up a new cluster, which we'd never really done before. But the other half of the team just did damage control, talk to people on Slack about how they can get around the dev cluster being down for the entire day. Whereas had we just had a secondary resource at the time, we could have found what we were doing and then figured it out without people being mad at us. So east-west deployments, use those when you can't do immutable, but do use immutable everywhere you can. And then encouraging organize your code into primary resources with their supporting resources in those specific projects. Those are the architectural patterns. Next thing I'll talk about code patterns.
Can I ask a question on that section?
Go for it.
So it seems like immutable architecture and east-west will both have some question of the database, which needs to be consistent. And if you're going to be migrating back and forth, how do you generally deal with keeping the data consistent?
That is left as an exercise to the enthusiastic reader.
I can give you a solution if you want it.
Yeah, there's lots of ways. There are a lot of ways to keep two databases in sync. AWS has actually several tools that let you do it.
I'm talking about another commercial software that you can use that is free, it's open source. YogiDB is based on PostSQL, and you can use it, and therefore you can cluster it. So you can actually have two synced up databases, one East Coast, one West Coast, and therefore you don't care. One goes down, spin up another one, the other one feeds it.
Yeah, so like, it's not easy, but there are tools out there to let you do it, and it's not fast. Depending on these tools, sometimes inside your database, sometimes it can take
Size
hours,
matters.
days, depending on like really large databases. But it is something you can do if you want to pursue these strategies. The other thing is you don't have to like go whole hog on, hey, I'm doing immutable everywhere, and we're just going to spend the next 6 months figuring it out. It's a lot easier to do immutable with stateless resources, so you can approach it there. Like if you're doing stateless EC2 instances or lambdas or stuff, you can do that really easily with those. And then as you mature with it, you can start like tackling the bigger things. The other thing about databases is you don't tend to update them as often, which is probably a good way with all the difficulty around them. So they're generally not at the top of the list of things I want to change anyway because of that.
So we did have a talk last month with a solution. They were promoting their software, but it handles. It was a really nice solution. They handle schemas through databases. So yeah, check out our webpage for that. Yeah.
Because all these talks are recorded on the internet. We talk about that. All right. So architectural patterns. Like I said, big things you're not going to be able to start doing tomorrow, but things to start thinking about. Code patterns are things you can start doing tomorrow.
This is app code.
This is infrastructure code.
Okay.
So I hate loops in infrastructure code. Loops are great in app code, but I advise against doing them in infrastructure code. And this makes people make that face,
Yeah.
or if they're a Pulumi sales engineer, they actually get angry at me. But I really encourage you to avoid loops in infrastructure code. App code, yeah, whatever. Definitely stuff they teach you in ComSci 101. They make infrastructure code so much harder to handle. And I have some examples of how it's bad. Terraform has a count construct. It was the original way you did loops in Terraform. And you don't use it anymore. You're actually supposed to use it as an if statement, which is weird. But back when Terraform first introduced it, this was like how you do a loop. If you're going to build a VPC, you're not going to have 10 subnet resources. You'll have one with a count of 10. And then when you need 15, you change one character and take the afternoon off because you are a smart engineer that's looping over stuff. And you don't use count anymore because it breaks down so quickly. Like, what if I actually want 12? But I want to delete the 5th, 8th, and 9th ones. You can't do that with a count. What if I want to change a single resource? Is actually the big problem. And that sticks around. Like if I want to change one subnet, I'll subnet to change that. If I want to change one resource in that, this will list the top watch alarms. If I want to change one of these alarms, how do I do that? And with count, there really wasn't a good way. So Terraform introduced for each. It's a bit of a change of direction. It allows you to pass an array of things and you can iterate over it. It's an improvement over count because you can say, hey, I actually want to delete Johnny's subnet and then go in and delete it. But you still hit a lot of problems with looping over stuff when you want to make changes to a single resource. So I was working somewhere, we had dozens of domains for our app. It was stupid, we only ever used one of them, but we had to support like 30 of them. And following Terraform best practices, we use for each. We have all the domains in an array. For each domain, create a route user resource, create a health check. 10 lines of code, 30 lines in the array, but 10 lines of code. I was tasked with, hey, these alarms are noisy because we only are waiting for one failure to ping slap. Can we change that to 3? Like, that's a pretty simple change. I can do that. But I don't want to do it for every domain. I wanted to test it with just one to make sure, like, what I think is a pretty simple change actually is a pretty simple change. And I couldn't. So if I changed any of the code, it would affect every single alarm we had in place. There are ways you can approach that. You can like yank one out, maybe do some state manipulation to like make Terraform happy with it. If you're using Terraform, I'm not sure you can do this without permission. You can just suck it up and say, hey, I'm going to change all 30 and hope it works. Which is what I actually did here, and it was fine. But I had to like check with the other engineers on my team, make sure they were cool with it, and like not like get approval from my manager, but let them know like, hey, listen, I'm doing this thing that I really don't want to do, and if it all goes sideways, you can't yell at me. So what could have been like a quick 10-minute change to test something out, let it run for a day, and then a 10-minute change applied to everything else, was then an afternoon of me like talking with other engineers, talking with my boss, get stuff approved. Not the best way to spend an afternoon. I did eventually just roll it out to everything. It did work, we let it ride, but it definitely wasn't like a safe way to make a change. Another time this bit me was a malware scanner. I didn't have a picture of coronavirus, but I just needed a virus, and that's the only virus you can find online anymore. I was working at like, not quite a startup anymore, but like a scale up. One thing the app did was it took customer provided files and stored them. And if you're ever doing that, you have stood up Clam AV to check to make sure that people aren't uploading viruses. So there was some founder code where they had stood up this malware scanner and then didn't deal with it for 2 years until I was working there and we got a CVE for the version of Clam AV we were running. So I go into the code to like, okay, well, clearly there's going to be a pipeline for building these images, and I have to like lots of scaling group, and it'll be easy. This was written. We're using Pulumi as a research code tool. It was a .NET shop, so they were using C# to write their Pulumi. The code for this was a while loop or for loop of like build an instance, put an ALB, build instance, put an ALB until we hit the number of instances we need. Which is a very like something a C# application programmer would write. I needed to change the images we're using. If I change it in the loop, I'm going to change everything in the malware scanner load balancer, which is not a good way to test it because no one's touched this in 2 years. I don't know what's going to happen. Basically, what I ended up doing was unrolling the loop and adding a third instance with my image, and then being able to like, I'll send like 10 requests of the icar.txt and see which ones cause issues. And there was a lot of back and forth, and eventually I was successful in unrolling everything and just having the instances. But it was a headache I had to deal with. And it was not a great time to have a headache because then the security engineer breathing down my neck, being like, the CD needs to be fixed right now, otherwise someone will use their phone to upload, I think it was like, you upload like a Linux image, an illicit Linux image, you do that, which is something someone would do from their phone uploading, trying to schedule up and look it up. So, after the CD, I went and put it in like an auto-sync group with a pipeline to build these plus images, but the loops are kind of getting me. So yeah, don't just write out a usual definition. It's more work. If you asked an architect to build you a house, and he came in and said, "Here's the room, just do it 6 times," you'd be like, "What the hell?" It is more work in the beginning because you do have to like draw out every room, but it's a lot less pain later when you inevitably have to change resources.
Hopefully no one goes back and, hey, this should be a loop.
Totally. This I don't have a lot about, but if you're using a tool like Gloomy or CDK that's used in your language, and you're at somewhere that's using a language like Java or C# that supports inheritance, do not use inheritance in your infrastructure code. That same founder code I was dealing with also had, oh, we have Linux VMs and Windows VMs. I'll just create a generic VM resource and we'll inherit it. And it was just a big old mess of stuff you think would be generic is actually just for Windows, but affects Linux, and it was a big problem. I don't think object-oriented programmers or app code say, geez, inheritance didn't work either. Inheritance is probably just like blacklisted everywhere. I saw this once. I just wanted to throw a slide up here just to get ahead of it. The other thing to do, you do in app code, but you should not do in infrastructure code is conditional logic. No if statements or anything like that. You don't want to do this because branching logic ruins everything. This has always been true, but it hasn't been a problem so recently because tools like CloudFormation and Terraform, while they supported if statements, they were so like cumbersome, no one ever did it. With tools like CDK and Gloomy, where you get an entire programming language, it's a lot easier to say, if prod, do this. If version 2x, do this. And this makes a messier code super quickly. And if you ever do say, okay, actually I do want to change how we do something in prod, and I have to, instead of just like changing a parameter, you're like, oh, I have to go find every single issue with prod. And okay, well actually this is UAT, this is not dev, or it gets really messy, very hard to manage.
So based on that, wouldn't you say, do you recommend Terraform over the other one, Gloomy?
Gloomy.
Probably not.
No?
I mean, I wouldn't recommend one or the other.
Okay.
I do have a recommendation at the end, but what I do recommend is don't do if statements. Wherever there is a time where you're like, oh, I do actually want to handle this differently for prod, take that little thing you want to handle differently, like multi-AZ or instance size, and just present it as a parameter that the user can set. It might make sense to say like, hey, I don't want to run multi-AZ and non-prod. why would I need that? 2 people use that environment a day. And that sounds fine to me now, but 6 months from now, when QA wants to run a giant performance test and they actually need a multi-AZ non-prod environment, they have to make that change, and you don't have to go through the code to make it.
Here's a possibility. I'm just wondering what your thought is. Because you're talking about resources and resource files that could be used with Terraform, you could then parameterize all those things that you said. So if you had the parameter prod that's in the resource file, those resources, let's say, gee, I don't need an 8 CPU, I need a 24 CPU. These are the things that could be then parameterized into a resource file that would be easily substituted into a generic Terraform setup. So therefore you can have dev, test, like as much prod, pre-prod, prod.
Yeah, so yeah, you could set up like a parameter set, but like this is prod, this is non-prod.
Because logically they're supposed to be the same.
Hopefully.
Well, that's why we're using Terraform.
You think that? But I've seen Lumi code where it's like if non-prod don't install.
No, I don't like if. I agree. No if.
But like I've seen people like if non-prod don't do a Redis cluster, which is not what you want to do. Instance types, the same idea. People get worried about instance types. They're worried, oh, if I let them choose instance type, they'll do the giant biggest cluster because they think they need it. All infra tools that I know of let you define the acceptable inputs. So you can set an array of like, these are the 10 instance types we support. Change the other ones. Another way to avoid conditional logic is something that people do in app code pretty frequently, but I've never seen anyone else do in infra code. And that's to do a lookup. In app code, we'll do this a lot where we'll say, hey, there's this behavior we want to do, but depending on runtime conditions, we want to do a different behavior. So we'll encapsulate the behavior in an object or a function, store those behaviors in a dictionary, and then at runtime, be able to look up the one we want to execute it. I've done similar stuff with infrastructure code, where you create a bunch of resources, and then at runtime, you decide which one you want to use and just wire that one in. I did this at a place where we were doing blue-green for Kubernetes clusters, when we did the upgrades at least. But we still had a lot of our projects set up by resource type. So where the Kubernetes cluster was blue-green, the IAM role was in a different project and was kind of static. So we're like, okay, well, we can deal with this by putting a bunch of if statements in our IAM role. And if anyone's ever put together an IAM policy, they are confusing even when they're simple. When they get complicated and you throw a bunch of if statements in a here doc, in a Terraform file, it's very hard to tell what's going on. I did not like it at all. So what I ended up doing was I created 3 policies, one for the blue cluster, one for the green cluster, and one for the blue-green cluster. We were running both clusters at the same time. They had to share the IAM role. And then at runtime, it knew which cluster we were working on, the blue one, the green one, or both of them. And we just select that one out. So all the policies always existed, but only one was ever wired in. It worked really well for this use case because IAM's free. You can create as many IAM resources as you want, and no one cares. I probably wouldn't recommend creating a dozen Kubernetes clusters and then picking out the one you want, because that has cost associated. But this was a bit confusing for the rest of the team to kind of see before. They were all system in to never see like this on app code. But they all, when they confronted with the alternative of a JSON document with a bunch of if statements in it, they came to like it pretty quickly. So code patterns. Do repeat yourself. Don't use the statements. I'll be done with that. So now I'm just going to rapid fire some techniques that could be patterns, depending on how you swing. first one, what you were saying earlier, you do want your environments to align as much as you can. This is less of a problem now, but I've definitely worked places where production was running this very expensive IBM operating system. So in non-prod, we ran some free Linux version, which was terrible because we'd have all these problems in non-prod that we couldn't reproduce, that wouldn't appear in prod, and prod problems we couldn't reproduce in non-prod.
That's a big problem.
That's a big problem.
I've seen it other places.
Yeah, that doesn't happen as much anymore because everyone just runs Ubuntu because it's free and works. But changing scale between environments is fine. Multi-AZ versus single node is fine. But you want to make sure all the same region is there. So I said earlier, like, oh, we don't need a Redis cluster or non-prod, we don't have the load. Let's get rid of it. That made everything a lot more complicated. By aligning your environments as much as possible, it makes it, one, you can kind of approximate and feel more confident in the changes you're making as you push into prod. But yeah, the only difference between your environment should be scale. You probably can do with less environments too, but that's a good problem. The other thing you want to do is make sure you're deploying via automation. The pipeline should be the only way your infrastructures get out into the world. This is a big one that a lot of people, it's really like table stakes for app code. But I've joined so many companies where like the second day they're like, hey, cool, you finished your security training. Here's access to here's production access, admin production access to all AWS accounts. I'm like, okay. So you want to push all your changes through a code pipeline, whether it's something you set up in Jenkins yourself or GitHub Actions, or there's tools like Atlantis and Spacelift, which do this very well for you. If you don't do this, mistakes will be made. An engineer will try to deploy from their laptop, but they will deploy from uncommitted code, or from the wrong branch, or they'll forget to merge their branch. Now that we have actual real code, it works on my machine. Although I've got now a Terraform where people bring along version of Terraform. Right through the pipeline, all that goes away. And the engineers don't need admin creds then, which is lovely. They can still have like very expensive read permissions. They can run things locally on their machine to test stuff out. But all changes go through the pipeline. It also is very handy because it gives you a record of changes made. There have been numerous times in my life where I'm like, man, I wish I had that Terraform output from 3 days ago to see what I broke. But when it lives in the Jenkins server, it's just there. You can look it up later. So always deployment automation. This is probably the most important thing. If you're not doing this now, this is something you should do tomorrow. This also prevents you from having to make manual changes. You should never make manual changes, except when you have to. So during a production outage, do what you have to do, get it running again. But make sure your incident process calls this out as like, hey, the incident isn't closed or even in monitoring until all the changes we made have been backported into our infrastructure code. Otherwise, they will be forgotten about because the change I made at 2 a.m. isn't quite as clear in my head as it was the next day. So, big part of your process, you make sure you do it. Another thing you can do is every day execute your infrastructure code. So have a loop that runs every night that just does a plan, or create a chain set, or whatever makes sense, whatever it's called, whatever tool you're using. And if it detects a change, that's a failure, and that's something that has to be addressed. So it'll catch the things you forgot to backport during the incidents. It'll also catch like people making manual changes because the founder still has admin access for some reason. Right? He was messing around last night. Or because sometimes the cloud providers change things, which sounds scary until you realize, okay, when I told RDS to auto upgrade on maintenance windows, that actually changes stuff that could be in the state file, and then Terraform will get mad.
So
yeah.
how long did it take you to run a plan when you said you have to run it at night? How long did it take to run to get your plan back?
It didn't take that long. I just ran at night because we just ran every night.
What, 20 minutes and you're good?
I mean, sometimes 20 seconds and you're good.
Okay. It's so small.
The bigger thing is that you're running every single project. You run every single project every night.
Yes.
So tools like Space and stuff will just run these in parallel and play with fail next morning.
Okay.
So it was just like the thing we did in the morning. It's like, oh, do we get an email? Okay, we have to figure this out before stand up.
And this is great. I don't know if we do this, but and this detects mainly the state. It's the state.
So if anything changed, so it'll detect manual changes made because,
Manuals.
like, really, it'll detect. Even if you're still running stuff locally, it'll detect, hey, someone applied a change from their laptop but didn't make it. Hey, AWS made a change to our RDS instance and we didn't write our code correctly to be agnostic to that change. Those type of things.
Right.
It gets rid of the problem where, like, every time you pull it out in your code base and make a change, you have to remember to run a plan before you make any changes to make sure there weren't any changes that you didn't make that you could deal with.
But it's not as good as just, first off, when we did this in the past, we did not have a system to run all the plants, okay?
Yeah, right.
We would rotate it per employee in the
Okay.
team, and we'd rotate it. So they all knew, we're all watching, we know what's going on, we would see the change and we would know it. And therefore then we had to account for it before we went up to our stand-up. And our stand-up was at 9, so everybody had to be in there at 7 and figure it out. And so everybody knew not to muck around, even in dev.
Between 7 and 9? Yeah. That's why you run in the middle of the night. No one's looking around.
No. We want someone to actually feel the pain. I don't want just an email. I want an employee to look at it because then they're going to call each other out if they start making changes and no one knows who did it.
I mean, this was like, this will notify the entire team, so it's going to call out just automatically every night. In that same vein, don't use targeted deploys. This is not something I think you can do with CloudFormation. Maybe you can now, but Terraform people love to do this. Fluent people love to do this. And a targeted deploy is just like, hey, I want to change this one specific resource because that's what I'm working on, and not these dozen other ones during this project. If you find yourself wanting to do a targeted deploy, it's a screaming loud signal that you are not grouping your project well. You have resources living in that project do not share the same lifestyle. You don't want to do this just because it makes life harder for the person after you, which often is you. Yeah, so what tends to happen is you'll say, hey, I want to make this change. Oh wait, there's this other change I don't know about. It's 7 p.m. I don't want to deal with it. I'm just going to target my thing and get it rolled out. Best case, the person comes in after you has to deal with the same problem you ignored, and they are now further removed from it, so it's going to be harder for them to solve. Other things that can go wrong are, one, this happens to be a lot. You target a deploy, you think you're deploying just to the EC2 instances, but oh, it had a tag-along change to security groups that you forgot to apply. So you didn't actually apply all your changes, and now the next person comes in has even more weird changes when they try to apply. But also the same problems of, hey, I forgot to merge my branch, I forgot to commit my code, I was working off the wrong branch. Those type of things all just like build up and build up and build up into just like this huge mess that takes forever to deal with. And then you're stuck using targeted deploys in the only ways that really condone, which is fixing this. If you have a giant mess of a project with a ton of changes that are unrelated, using targeted deploys to iterate over that does work very well. But I really recommend just don't use targeted deploys and never get in that situation in the first place.
And how, I've never done targeted deploy. What's the command in Terraform?
So it's like Terraform apply -target, and then you use the Terraform resource locator.
Okay.
So it's like
Yeah.
aws.eks.cluster.Johnny Sywulak cluster.
Okay.
Now I forgot what he said.
Yeah. Yeah, so I know Terraform supports it, I know Pulumi supports it. I don't know if CloudFormation does, and I don't know if CDK does.
but you're talking about something that's outside of source control, right?
So you would do a Terraform apply, and you're expecting one change, but 3 changes come back. You say, I'm only going to target the one change I want to make, and the
How
other
do you-
2 I'm just going to ignore.
All right, then how do you then go through the approval process? Because everything that we used to do, in order to actually merge into a branch, okay, or the root, I should say, you're in a branch, you're working on something, fine, and you want to merge into root, okay? There has to be a review process, and normally minimum was 5 people. 5 people have to go through it and say, okay, we agree. Therefore, it's not one person that can just go in there and target apply, and therefore you have 5 people that are now answerable for what happened.
So do you have a pipeline deploying your changes?
Yes.
Okay, that's the trick. Like, if you're doing targeted deploys, you're probably doing it manually. You're probably doing it from your laptop. So in those situations, like
We had a pipeline that actually ran it like a Jenkins.
Right, yeah.
So
I'm saying
Jenkins
that-
ran it, but if you then approved it and put it into root, root would then be seen by Jenkins. Jenkins would then pull it.
Jenkins isn't involved in this. So this is like in a situation where I'm on a DevOps team that doesn't have a pipeline. When I make an infrastructure change, I have to run Terraform apply from my laptop.
Yes.
So even if you have like the 5 people reviewing it, it's still me going in and running Terraform apply manually.
Yes.
So
5 people approved it.
yeah.
Therefore, the mistake is collectively, and therefore they all have to get in there and fix it.
But it still has to be fixed. If you just don't do it, it doesn't need to be fixed.
It should not happen.
Yeah, it shouldn't have happened. That's what I'm trying to say.
Somebody should have stopped it.
And ultimately, don't fuck with state. Fucking with state is a very strong signal that something is wrong and you can't update cleanly. I'm the strongest advocate I've met to say don't mess with state. I will avoid messing with state as long as I can. But at every job that's been a Terraform shop, a Kubernetes shop, it still had to happen for whatever reason. So I assume you're going to fuck with state at some point. If you do, make sure you back it up. Before you make any state changes, always do an export through the tool. It doesn't hurt to, if you're like storing your state in S3 bucket or Azure storage blob, it definitely doesn't hurt to version it, but I know for Kubernetes, I think it's true of Terraform as well. The state file that exists in your S3 bucket is not the same thing you get when you do a Terraform export state. It's also not the same thing you do a Terraform import and pass that in. For Pulumi, you can do some like JQ massaging to get it to be the same thing. Terraform, I think, actually is binary, so you don't want to mess with that. But yeah, always use the tool to modify state. Never try to use your editor, because it's doing stuff like versioning and checksums, and just don't fuck with state. But if you do fuck with state, fuck with it through your command line. And finally, my most contentious one, I think the last. When choosing your infrastructure as code tool, favor ones that are API driven rather than ones that are like Git driven or depend on code input. This is my fuck it up slide. I said earlier that I didn't understand. I thought I had this theory why immutable infrastructure isn't as widespread or as it seemed to be, was going to be in like 2015, and it's Terraform's fault. The way you create resources CloudFormation, you create a template, you hand it to the CloudFormation API, it creates the resources. Terraform, you create your Terraform stuff, their main TF, you call a Terraform apply, it creates the resources. When you decide to do a new environment, you just call, for CloudFormation, you just pass in the same template to the API and it goes. For Terraform, okay, well, is this living in the same project or a different project? Okay, it's a different project, so they create a whole folder with a new main TF, and if you're doing like your state yourself, you're like, okay, well, it's backend, like, I don't know what's the name for that? And it's just some friction. It's not hard. It's not even really tedious. It's just a little bit of friction. And a lot of times people be like, actually, well, this comes in the same project, it's fine. Or I'm actually just going to update this, it's fine. With different life cycles, this is just like, it's not really related to this, but I don't want to go into a project just where I'm roll, so it's fine. And you end up with a lot of the things I was trying to avoid today, because your tools are want stuff in source control, not just stuff headed to an API. The other reason I say to prefer API-based tools is because you can build on top of them a lot easier. I was working at a large company once. We were spitting out AWS accounts at the rate of like 2-3 a week. We just had to hand them out to different teams very quickly. And part of that was like, hey, we had to install VPC and all that, but also we had to like talk to the IP management software to get a CIDR block. We had to talk to the certificate management software to get a certificate. So we wanted to have this all living in Lambda step function. And we were a Terraform shop. We wanted to use Terraform. Some of the resources we were setting up were the S3 buckets to store a Terraform state. And we actually had an internal tool that was supposed to let us call an API to use Terraform to build resources. We just never get it to work. We spent probably 2 weeks like hacking at it, trying to get this to work. The rest of we just gave up and said, we're just use cloud formation. Pass it to an API and like boom, we have a VPC. Fit very easily into a step function. We would have built other tools on top of it. We got something that was an 8-week process that multiple engineers had to do, to something that like a project manager hit a button and then they got an account in the end. It's just something we couldn't do with Terraform. This was 5 years ago, so definitely tooling has improved. Terraform Cloud I think works a lot better. And CDK actually, which is built off of CloudFormation, works in a more Terraforming way than it wants these config files. Well, they kind of try to split the difference, but when given a choice now, I still will generally reach CloudFormation. To your point earlier.
Yes, thank you.
So those are the techniques that I want to talk about. That's the end. So thank you all for coming out. Thank you too for setting this up. Thank you to the library for letting us stay. But actually, thank all of you for coming out. One thing I've found is that this type of thing where we all like go to work, leave work, go somewhere else to talk to people we don't work with about work, that's unique. Like dentists don't do that, lawyers don't do that, professors of Italian art history don't do that. So I think from just like a, hey, I think continuous improvement's important, that's great, so snaps all you. But I think it's silly that we do that, like working in software delivery and deployment. Software is so pervasive to our lives. Like everyone goes to the dentist, everyone needs a lawyer sometimes, but everyone uses software all day, every day. And us like moving the needle a little bit to improve that has a huge impact across the world. So snaps to all of us for just coming out tonight.
I second that. That's
Thank
great.
you.
Yes, thank you very much.
Thank you.
If you want to keep in touch with me, I have a Twitter. I'm actually not from Maryland. I'm from Philadelphia. Philly has a lovely dev Slack if you're out there and want to hang out. Or you don't check. You don't like show ID. You just join it. You also come work with me. I'm with a company called ReArc. We are cloud and data consultants. If you want to spend your time talking to very smart people, like my friend over there, about this kind of stuff and debating it, we are hiring. That very ugly link will take you to our hiring page, or you can just reach out to me on one of those things and I will walk you through it. We're hiring for cloud engineers and data engineers, a lot of other things too. Anyway, does anyone have any questions?
Could you put the slide back up? I need a big picture.
Yeah, sure. That's an easy question. Let's do that. Any other questions?
Thank you.
I have some questions. So these are just, so you talked about the backport process.
Yeah.
What is your best, what do you recommend for a backport process?
So like when you're in an incident, you have to like take a manual change and put it back in?
Yes.
So that was more the incident process. So if your incident process has generally most of them are like, hey, stuff's on fire, and then like, okay, now we're monitoring.
Yeah.
Before you move that monitoring step, but definitely before you close the incident,
Yeah.
that has to happen. It has to be like something that's called out as, so like when we were working on an incident process, that was one of the things. It's like, hey, can we change state of the incident? It's like, are there outstanding infrastructure changes? Are there code changes you have to make?
You have to account for what you change.
Yeah.
So do you move it? You made a change in prod. Do you move it to the lower environment, or do you start back from dev and come up?
Depends on the change. It was just like, hey, we increased the number of pods we're deploying because we wanted to handle more load. That problem is load. That's not something we had to test in non-prod. One time that it was a bigger problem was in Azure. The SQL Server has this idea of SQL Server pools, where you can share hardware resources between separate databases. We popped something out of a pool in prod, and we're like, okay, what do we do now? Do we do that in non-prod as well? And we talked about it, and we're just like, actually, the resolution here is we're going to leave it out until the code is fixed for the, it's an indexing issue.
Yeah. Yeah.
It's a SQL problem I didn't understand. But once that was applied, we pushed it back into the pool, and that was the resolution. So we'd actually make a code change there. We didn't close the incident for a couple of days and made people mad. He was like, okay, no, we have to fix this first.
Right. Very good answer. The next one. So I'm not up to date with the Terraform license change. Does anyone have an overview of? But I hear people complain about it.
I mean, I'm not super up to date, but
It's basically new improvements for Terraform that you think, like let's say AWS comes out with a new product. Most likely it'll be in the corporate space so that you actually have to pay for this service, and it will not necessarily as quickly run into the open source side of Terraform. So if you wish to also, let's say, control your security pieces like passwords, maybe tokens, anything else, you can then put all of these things into the corporate Terraform, which is Heroku? No, sorry, I can't remember the company now. HashiCorp, thank you. HashiCorp. So you can go out to HashiCorp, you can sign up for an account, and I think they'll let you play with their corporate side of it. But as I said, they're just moving things so that they don't want to give some of their new ideas out to the open source community.
yeah, it's less new AWS like services and more Terraform features. And as it stands now, like there's still a free version of Terraform that supports this stuff.
And you download it from them.
But
Okay.
because they changed it, it's no longer going to be free forever.
Yes.
So there's a fork called OpenTofu.
Yeah, that's the one.
And their goal is to stay
Sync.
in feature sync with whatever Terraform does. As far as I know, Terraform hasn't released anything to really like a breaking change.
No, they have not even said what their direction is. They're being very tight-lipped about it. My only best guess is that they're going to be pushing into the AI space and how they can make it more easily readable to like manipulate the resources, whether it is through AWS or Google's cloud or Azure. Each one of these companies are pushing more AI, more compute space out in the wild, so that they're even talking about the cost of energy is being affected by these companies that are buying these GPUs in mass quantity.
Oh, yeah. Oh, yeah. So you didn't talk about AI at all.
Sorry.
Did you want me to?
So where you're I haven't been keeping up with AI in the infrastructure as code space. So
Copilot supports the stuff, like all these tools. So you can use it there. The thing about infrastructure code is it's not hard.
You just have to be diligent at it.
Yeah, like a lot of these,
I mean, really diligent.
a lot of these patterns are definitely not going to show up in Copilot. Yeah, like it can definitely do on the boilerplate for you very quickly. So
Right,
like,
right.
hopefully it'll make like, okay, I don't want to deal with setting up a new backend.tf file, figuring that out. I can just do that with Copilot. That would be nice.
okay.
But I've not seen, at least for infrastructure code, like a killer app in terms of like AI. I don't know if anything else has.
So I have one last question. So if you were just started a brand new startup in Columbia, Maryland, it's a hot new startup, and you're going to do a whole infrastructure, what would you start with?
I mean, I'd probably start with CloudFormation.
Yep. Okay.
I don't think that's probably a popular answer.
That's good. So
But that's not movable between different cloud providers.
right is
Yeah, but is it ever? Terraform's not even really movable. Like, you still have to rewrite Terraform. Like, it doesn't have to use
yes. So the
AKS or
objects, the
EKS.
IAM roles, and everything are different between every cloud provider. So
Yeah.
let's say you write one,
yeah.
but the same language and the same techniques that you do by learning one language is easier than
Oh,
like
sure.
learning one cloud formation versus Azure's cloud formation.
Well, sure, but it's still not cloud agnostic.
It's
Yeah,
not
it's
agnostic,
lift
but
and
it's
shift.
at least as
I've
removed as you can get.
I
Okay.
have seen vanishingly few companies actually move cloud providers, so I wouldn't stress.
So
I
we actually my day company work moved from AWS to Google Cloud.
Wow.
Yep.
We had a contract with Google, and
It was motivated.
it was so what our company is one of the premier Google something.
Yeah, we're on like some page on there.
So we moved our AWS to Google Cloud.
You moved all your workloads from AWS to Google?
No, so we moved
Go
compute.
Flex.
We moved
Still some S3 stuff.
S3 still there, DynamoDB's there.
Yeah, we're slowly moving stuff over.
We're
But-
slowly
But
moving.
yeah,
Yeah, Spotify
main
moved
compute is all moved up on that.
something over as well. I think
I'm sure it's all
they moved their
cost.
compute to Azure, but they kept all their data in S3.
The interesting thing since you
Google
said
Docs.
cost, it's the same cost. Google Cloud and AWS do similar costs.
Really?
Yes.
Yeah, I haven't followed up to see
No,
how
I
it actually
did
worked
talk
out.
to
It was,
him.
it was supposed to be cheaper.
It's not cheaper, but
Okay.
the ops guy said the networking performance is better in Google Cloud.
Okay.
That's what they've noticed.
Well, the only thing I can say to that, when you're talking about even different vendors, the one thing that you want to put your hand on is to actually improve the needle for cost is to fight latency. Latency of the startup of any process that you have, whether it's a database, or whether it's a CPU of something, some process, or even Kubernetes. The same idea so that you can start up and minimize your costs so that it is just in time that it starts up and it doesn't cost you anything for it to start, so that you are in the microsecond area. That's what you want.
And that goes along with your immutability, right? If things start up faster, you can you don't have to do
It's easier to do building when things are.
right, yeah. Oh, good point.
Anything else?
No, that's
Does
all.
anyone else have any questions? Or comments or feedback?
I love a lot of the points you're making. They resonate very, very strongly with aspects of software engineering